Hi again, guys. All right, we're talking about objective 3. This is all about our circulating and our local hormones. So those ones that are going to circulate throughout the blood and those local hormones that are going to be affecting the cells that are close by to them. So we've got 4 different goals here. Not a whole lot of information though. So we're looking at the 3 structural categories of circulating hormones. So there's 3 different structural categories, and we want to think about some of their examples that are within each. And then we want to distinguish the hormones that are lipid soluble from those that are water soluble. And so we'll talk about those along with the different structures. And then we want to describe the general structure and the formation and function of local hormones, and we'll specifically focus on one of those. And then we want to compare autocrine and paracrine signaling that's going to occur within our local hormones. All right, so our first category of circulating hormones are going to be steroids. These are lipid-soluble molecules. So remember that they're coming from cholesterol. So cholesterol is a form of a lipid, so of course these are going to be lipid-soluble. And they're going to include our gonadal steroids. So that's going to be our estrogen, our progesterone, and our testosterone. Those are 3 really good examples. You're wanting to think also that these are steroids that are synthesized by the adrenal cortex, right? So this could be cortisol, our stress hormone. When we get stressed out, we go ahead and release cortisol, and that is a type of steroid. Another type is calcitriol, and then this is sometimes classified as a steroid, but a lot of times we'll consider it more as a sterol, so it's just a little bit different than steroids. Our second structural example of circulating hormones is going to be our biogenic amines. So these are modified amino acids. Remember that amino acids are the building blocks to proteins. Okay, so just like nucleic acids are the building blocks to DNA and RNA, amino acids are the building blocks to proteins. Okay. So these biogenic amines are going to be modified amino acids. So they're going to be like catecholamines, the thyroid hormone, and melatonin. These are water soluble, except for the thyroid hormone. Okay, we call that TH in short. So TH is nonpolar, so that means that it's going to be lipid soluble because it's made from tyrosines. So they are going to have that nonpolar edges to them that makes it so that they're only lipid soluble versus water soluble. But all the rest of them in the biogenic amines are going to be water soluble. Okay, so again, that includes our catecholamines and melatonin, and then our thyroid hormone within that, but that's the only one that's lipid soluble. All right, our third one is proteins. So this is the biggest one, right? Most of our hormones are proteins, and they're all water soluble, and they're just made of chains of amino acids, okay? So those are our circulating hormones. And then we go to our local hormones. So these hormones are signaling molecules that aren't going to circulate in the blood, okay? So some biologists don't really consider them hormones because they're acting locally, but depends on the biologist, right? So one of our examples of these are eicosanoids, and these are a type of local hormone that are formed from fatty acids. So remember that fatty acid chains we can find in the phospholipid bilayer of the cell membrane. Okay, so they're the little 2 tails that are coming off of the phospholipid. And what's going to happen is you've got an enzymatic cascade that's going to go ahead and take some of those fatty acids and change them into these eicosanoids. So one of the ways that we go ahead, how this is produced, is we phospholipase A2, which is an enzyme, is going to remove the arachidonic acid from the phospholipid. So we have an acid, arachidonic, that we go ahead and take from the fatty acid, and then we have this enzymatic cascade that's actually going to change it to a subtype of an eicosanoid. Okay, so we're going to actually change that fatty acid little piece that we took off, that arachidonic, and we're going to change it into an eicosanoid. And so one of the things that we notice that these guys do, these local hormones, is they're going to either have an autocrine stimulation, which is going to be that they're affecting the same cell where the messenger was found, or it's going to be a paracrine stimulation, which means that it's affecting neighboring cells. So either this eicosanoid is going to go ahead and affect the same cell where it was sent from, right, where it was synthesized from the cell membrane there. It might be actually affecting that same cell, or it's going to be a paracrine stimulation. So it's going to be the ones that are right next door to it, okay, those neighboring cells. Remember, auto is going to be like same. So autocrine stimulation would be like, oh, I'm going to go ahead and affect my own self to go ahead and do something. That's what the cell would be doing in this local hormone example. Another example of icosanoids is the prostaglandins, and they are actually one of the ones that stimulate things like cramps. So ladies, you can blame prostaglandins for that. They stimulate pain and inflammatory processes. Aspirin and other non-steroidal anti-inflammatory drugs are going to block prostaglandins formation, so they can't actually act locally and cause, that pain and that inflammation response. All right, so make sure you go through the check for understanding, looking at insulin and how prostaglandins are synthesized, thinking of those icosanoids and how they work.